Welcome to SND College of Engineering, Yavla. In today's lecture, we will discuss the unit number 3, which is partial differentiation. The contents involved in this unit are: first, we see the introduction for the function of several variables. Second one, you see the concept of the partial derivatives. After that, the Euler's theorem on the homogeneous function. Next, the partial derivative of the composite function. Next, the total derivative. And sixth one, the change of independent variables. So the one by one we will discuss these all contents. So the partial derivative, we know that the partial derivatives are very important in the wave equation, one-dimensional heat equation, two-dimensional heat equation, and to check the differential equation exact or not, and number of application for the partial derivatives. So the first we see what is meant by the function of several variables. If z has one definite value, for each pair of values of x and y, then z is called as a function of two variables x and y. So we denote the function by using the notation z is equal to f of xy, or we use in f of xy only, or phi of xy. These are the number of notation we have to use to represent the function of two variables. In this notation, the z represent the dependent variable and x and y are independent variables. For example, z is equal to x square plus y square. If we substitute the different pair of values of x and y, so we get one definite value for the z. So here z is a function of two variables x and y. Similarly, u is equal to f of x, y, z is a function of three variables x, y, and z. Here u is a dependent variable and x, y, z are the independent variable. So for example, u is equal to x into y into z is a function of x, y, z. U is a function of three variable x, y, z. Now next we see how to find the partial derivatives whenever the function contains more than one independent variables. So let z is equal to f of xy be a function of two independent variables x and y. So here we take the function in which the two independent variables are involved. So first we see the partial derivative of z with respect to the x is nothing but the ordinary derivative of z with respect to x, treating the other variable y as a constant. So it is the derivative which is to be denoted by using the notation da by z by da by x, or we can denote da by x, or we denote by using the notation fx or zx, or da by u by da by x. These are the different notations we have to use to represent the partial derivative with respect to x, and we read it as da by z by da by x. So Similarly, the partial derivative with respect to y, so the partial derivative of z with respect to y is nothing but the ordinary derivative of z with respect to y, treating the other variable, that is a x, as a constant, and we denote it by dabba z by dabba y, or dabba f by dabba y, or f suffix y, or z suffix y, or dabba u by dabba y. So these are the different notation to denote the partial derivative, and we read it as a dabba z by dabba y. So the partial derivatives is to be find. So the next remark 1. The partial derivative dabba u by dabba x and dabba u by dabba y are called as a first order partial derivatives. All the rules of differentiation, ordinary differentiation, are applicable in partial differentiation. Whatever the rule are to be defined for the ordinary derivative, that is a derivative which is to be find if the function contains only one independent variable. Such a derivative is called as a ordinary derivative. Whatever the rule are to be defined for that ordinary derivative, all rules are to be applicable in the partial differentiation. So in next lecture we see some rules for the partial differentiation. Thank you.